What is the acceleration vector for free fall? So we all know things fall down, right? So would it be too surprising that if I said, let's draw the vector representing acceleration for free fall, that maybe I should just draw a vector that points straight down? So I'm going to say here is that vector. And I think just for fun, I'm going to, sometimes when you draw in pictures, it's optional whether you want to put the arrow for vector, but I'm going to put it there and say that is that vector. But what else do we know about it? Because it's, this question is kind of open and it says, what is it? Is this an adequate answer? We know that we can say things about components. In other words, I could say like, well, what is the x component of this acceleration vector? What is the y component of this acceleration vector? Well, given the fact that it points straight down, wouldn't it make sense that there is no horizontal component to this vector? So I can just safely put in 0 for that. And then for the y component, what should I put there? Well, one of the things we know is that the magnitude of free fall acceleration is represented by the symbol g, right? So everyone remembers kind of g, right? Let me write that somewhere here in the corner. G, in other words. And we know that we've kind of looked at this before, that maybe there's two conventions one could work under. You can either define that g is equal to positive 9.81 meters per second squared, and some people, if they like, can also give this a definition where it's negatively defined. I prefer not to do that, and for this class, my general convention is when you see a g, it always is just equal to this, and if there's any minus sign that's needed, it's going to be explicit. And I think if that's the case, then if I want to say what is the y component for this vector, I'm going to give the answer that it's minus g, because I think the magnitude of this vector should be equal to 9.81 meters per second squared. In other words, if I were to plug in the value for g here, I get for this component minus 9.81 meters per second squared, which has the effect of making the magnitude equal to 9.81 meters per second squared. Really, this minus, together with the 0 for the other component, basically carries the information that this is a vector that points down. So really, I think with those two statements there, I feel like I've answered the question. And I'm going to go and check my answer, and you can see it basically matches. I've got a sub x is equal to z, and a sub y is equal to minus g.